there's tons of Ford V10s at junkyards that you can get for close to nothing.
Also, like we were seeing people were trying to tackle this, make a 4-valve V10, and no one ever, was able to complete it. So that was like kind of the, you know what?
Let's see if we can do it.
Yeah, let's see if we can do this shit, right? Let's see what we got.
Welcome to the Tuned In podcast. I'm Andre, your host. And what do you do if you want an F1 sounding V10, but you don't have the budget for perhaps a Lexus LFA engine or maybe a Carrera GT Porsche engine? Well, you build it yourself, obviously, and that's exactly what Jack and Diego from the YouTube channel Build It Yourself have done. They took a Ford V10 2-valve truck engine that no one really considers as a performance engine and decided to base this as their build for a high-revving, high-power, naturally aspirated V10. First thing you're going to need if you want to do that is to ditch the 2-valve head and go with a 4-valve design. But Ford don't make a 4-valve V10 cylinder head. So what do you do here? Well, of course, you take 2 cylinder heads and you cut them apart and you weld them together. And that's just as challenging and difficult as it sounds. But of course, Jack and Diego have managed. Today, we talked to Jack and Diego about their background, how they build up their skill set that they've got, and how they're leveraging a lot of the technology available that's now starting to become affordable to us at the enthusiast level. I'm talking here about technology like 3D scanning, 3D printing, and of course CAD, how they also learned their fabrication skills, and how their do-it-yourself mentality has panned out with this particular project, where this V10 has been put into a 2017 front-wheel drive Ford Lincoln Continental. Just a note here, it's definitely no longer front-wheel drive, so don't worry about that. It's essentially an amazing build and an amazing amount of dedication that's gone into it. There's a lot to take away here for every enthusiast that's got a project going on in their shed as to what you can do to speed that project up and stick it out, see it through to the end, and also leverage some of these technologies that are available to get a better final result. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, Jack and Diego, welcome to the podcast. Thanks for joining us today. And like we always do, let's start by finding out a little bit about your backgrounds. Maybe we'll start with Jack.
Yeah, so I was born in Ceres in California. My parents owned an auto shop. So really, I was born into a mechanical-minded family. My dad, my grandpa all did mechanic work. They owned the shop. So I was there a lot and learned how to do automotive repair, just typical automotive repair, spark plugs, brakes, all that type of stuff. So ever since I was young, I was going to the shop visiting, and that's where I learned and got engaged with cars. So from an early age, I was just brought up into it.
Predestined to tinker with cars for the rest of your life.
Correct, pretty much. Just here it is. This is what you're gonna do. So
There's always a difference between tinkering with cars or running an auto shop though, and performance related stuff, which obviously you're both doing now. So how did you kind of change the trajectory towards the performance side of things?
I mean, working on cars, like doing brakes and spark plugs, it's not really, it's a job. Yeah, it's not fun. So it's work. But I always was interested in automotive and cars, and get into performance type of cars. So like my first car was a 64 Ford Falcon that I still have. I bought that when I was like 15 years old. So just in high school, and I wanted to do an engine swap. So I swapped in fuel injected 302. I had the shop there, so I was able to use that, and that was my first automotive project, I would say. Up until then, I was always reading Jegs and Summit and choosing out parts from the catalog. Oh, I'm going to build this big block Ford. So I would spec it out in school, but didn't have the money to do that. So
the number of builds I've done in my head that have never come to fruition, and honestly, that's a great thing, both financially and from a practicality standpoint. Sometimes they're just better left in your imagination. Much cheaper place to build cars.
Yeah.
All right, let's just get Diego to the same point. So at this point, you've obviously done your first engine swap. You're at high school. So Diego, give us your quick background.
Yeah, I had a very different growing up. So I didn't really touch my first car until I was 18, when I was able to buy my first. It was a 1999 Saturn SC2 3-door. Yeah, I mean, I was always a hands-on person I was very into like Legos and puzzles and stuff. So I just like using my hands, building things. But I didn't really get into cars until I started playing, funny enough, Gran Turismo, Need for Speed. Like video games is what got me into cars. And then just, I think naturally, my love for using my hands and then cars kind of just got me into this level where as soon as I got my first car, I remember the first thing was I Googled how to change your oil. And that's the first thing I did on my car. I changed the oil. I changed the transmission oil. Then I got started doing like bolt-on stuff. Like I got an intake for that car. I changed the wheels, brakes. And it has kind of progressed into, over the years, more and more and more. And I mean, ironically, most of the stuff I've done or learned has been through YouTube, watching videos of people doing it, absorbing it, and then trying it myself.
It's definitely a valid way of learning these skills. Unfortunately for me, back when I was trying to build my first drag car, it wasn't in existence. So I had to kind of muddle along and figure it out the hard way. Scrolling forums back then was kind of the way, and now I'm just showing my age, so maybe I'll pipe down. In terms of sort of your formal education and qualifications, if any, Diego, just sort of give us a rundown on that.
Sure. Actually, I think it's kind of the same for both of us because we went to school together.
Okay.
That's how we met. So we're both mechanical engineers. We went to school in California.
UC Davis.
UC Davis, that's right. And yeah, so basically same education between the two of us. That's how we met. Funny enough, we didn't really talk much in college.
Yeah.
I think we had like maybe one class together.
I mean, we did Formula.
Yeah, we did Formula SAE, which is kind of, I think.
Okay. At this point, I feel like we almost now have a prerequisite. In order to be a guest on this podcast, you have to tick the box of mechanical engineering and Formula SAE. It's, I would say maybe 60 or 70% of our guests have really gone down that path. So it's a proven way to success.
It's definitely a nice segue, right?
Yeah.
It's like the first kind of hands-on experience you get with that type of setting.
Yeah. Not, unfortunately, when I went through uni, Formula SAE here in New Zealand just wasn't a thing at my university. And I was always a little jealous of the universities that had that. I mean, I think just from what I know about it, the people we've talked to on the podcast, it's definitely going to set you up for success if you want to make a career in the performance automotive industry. I'm interested, though, mechanical engineering, as we discussed many times, is such a broad field. and can be applied to numerous industries. So did you go into mechanical engineering with the intention of being somewhere in the automotive field?
Personally, no. I just happened to get a job in the automotive industry out of college. And I really don't like interviews, like, job interviews or like having to apply and stuff. So I took the first job I got, basically.
Okay.
And that's how I ended up here. you know, Worked out great. So
Well, fill us in. What was that job?
I work at Ford.
Ford. Okay. Right. And what's that sort of look like? What's the daily?
Yeah. So I work in the product development group. I work in the brakes department. So multiple projects, but basically I work in the group that works on producing brake systems for most of our vehicles.
A couple of people I've talked to have sort of worked for larger OEs. No disrespect here. Some of the jobs sound maybe, how would I put this? Not overly engaging or enthralling. There'll be a guy who works on the left front indicator of XYZ model for 3 years and then moves on to maybe a big step up, the headlight on the upcoming model. Is that sort of reality?
I think yes. There's certainly exciting times, like when there's a problem that you get to be very engaged in. Like high, like urgent things that you have to kind of fix quickly. You work with a lot with suppliers, with the plant. But I think the majority of the time, just by the nature of how long the product development cycle is, right? You're going to go through periods of time where you're just pressing buttons, sending emails, presentations, but not a lot of progress. Certainly not a lot of hands-on. Like I barely ever touch the parts I work on.
Okay. All right. Let's switch sides. Continue your story.
It's similar. So yeah, like I said, I was always around cars, and I knew I wanted to do more with cars, but more of the brain side. So I wanted to go into mechanical engineering. Got into UC Davis and did mechanical engineering there. But I always wanted to work at a OEM. That was a goal, I would say, but I didn't think I would be able to achieve it. So when, I applied to multiple places, did few interviews, but luckily I also got hired at Ford. They liked the FSAE guys. So I had my initial interview there at the event. So that's how I got into that. And that was the job I would have wanted. Instead of doing more performance or brakes or something physical, I'm in the hybrid electrified vehicle division. So I work on, right now I'm doing like battery systems, battery packs. So that's my realm of expertise at.
Okay. Side quest here, just with the full EV, hybrid, internal combustion debate. We're sort of seeing a big drive over the last 10 years, I guess, towards full EV. I feel there's almost a bit of a pushback now against full EV. We're seeing other manufacturers like Toyota embrace hybrid. Where do you kind of see the future with your insight and your experience?
Well, to satisfy the most people, the plug-in hybrid seems to be the way the market is going to trend, right? Because you're going to get the ability to have gas and electric. So when you're cruising around town, right, you don't need the mileage, you don't have the range anxiety. But then if you want to take the car farther, you're going to have the gas option to take you there. The only drawback, of course, is cost and complexity of the system. But
yeah, I'm glad you brought that up. That's kind of one of the hurdles I kind of see with it. I mean, obviously they're out there, it's proven it works, but now you've got kind of the complexity of both an electric vehicle and an internal combustion engine. You've got two systems that I don't know, could maybe join up to double the potential faults that we'll see in the future. I don't know.
Yeah, that's a risk I see of that. It might be a stopgap. I don't know what the final solution. I really think, electrified is the right solution for an appliance vehicle, right? You want to get to A to B, you want to do it most efficiently, full electric. But till battery gets, caught up with the demands of users or people acclimate to that mentality, PHEV is going to be I think the way we go.
Yep. Yeah, that's fair. Totally understandable. It's pretty clear to see why both of you have gravitated towards Ford-based projects now that I've got a little bit of insight into the backstory. So we've essentially got your qualifications, and now we know where you're working and what you're doing. In terms of the skills that you use on the Build It Yourself YouTube channel, what would you say individually each of your key skills are? Let's start with Jack.
Yeah, I don't think I've pondered that question. If I were to say something, it would be like really choosing something that I want to do and following through with that would be my skill set. Like,
That's harder said than done, actually.
yeah, being like meticulous and trying to, getting too deep into the details almost, but like trying to figure out how to achieve that solution is probably my skill set. That's not like metalworking or welding or, X, Y, and Z, but
It's like a means to an end kind of
yeah,
thing.
that's what drives like my ability to learn these things. Like welding, I would say is one of my passions from doing all this work. I really do enjoy welding. So like I took a class to try to get better. I did most of the welding on the car so far, and it's just like I enjoy that. I don't know if it's if I'm good at it or necessarily going to do that for a future for a job, but I just enjoy doing it, melting metal.
It's funny
So,
you say that because I remember you hating the day after welding the whole exhaust system. You're like, I'm done with
yeah,
welding for a week.
doing that in a short time is not fun, but
I used to do a mild amount of welding, and particularly with TIG, I think it's a combination, understanding the technical process, basically how it works and how to set up your machine. Clearly, no amount of practice on the end of the torch is going to get you good results if you've just got your setup completely wrong. But I think once you understand that and you've got your setup dialed in, going from average results to weld porn results is literally hundreds if not thousands of hours just getting the practice in, and that's the part that I never really sort of got to that level. I just had too much other stuff that I was doing, so it's hard to focus on just one thing. All right, Diego, give us your take on that.
Yeah, let's see. I think for me, I just like doing things, fixing things, like solving problems, and stuff like this is like a good chance for me. I think, like you mentioned, a lot of my day job is pretty mundane, I'll say. So this is kind of like, okay, I get to do the stuff that I actually enjoy. And for me, it's just learning new things, using my hands to actually fabricate things. I love just building things, and I'm really into like Frankenstein type of builds. So this was clearly a fun idea in my head for a while. We were both thinking about this, and it was just something that I really wanted to do. And I like learning things, so I didn't really have any fabrication experience before we started this. Right, it's all kind of been a learning experience. I think the willingness of wanting to do it, and just I know I'm not going to be the best at any particular thing, but I just want to try it, see what I can improve on. And I don't know. I think we complement each other very well because Jack is very much, that engineering mindset is always there. Like he wants to find the optimal, best, most efficient way of doing things. And I feel like sometimes that hinders like when you actually do it. And then I'm just like, let's just grab a torch and start cutting or whatever, like.
Yeah, I think though that synergy between the two of you, Jack maybe getting stuck too down in the weeds with analysis paralysis, if left to his own devices, maybe would never see the light of day, nothing would come to fruition. Maybe the other side of things with you might be it gets done a little too rough and ready, but you get the job done. So when you kind of combine that, you get the best of both worlds. In terms of what I see on your YouTube channel, though, you're really heavily leveraging a lot of the technology that has more recently dropped to what I'd call sort of affordable level at the enthusiast in the enthusiast market. So obviously you've already talked about TIG welding, and that's an essential part, but I'm more talking here about 3D scanning and 3D printing. How hard is it to go from zero to learning those skills? And obviously modeling with CAD comes into this as well. The three sort of go hand in hand.
I mean, the 3D scanning side of it, I think I would say is pretty low to moderate of an investment in terms of like building up the skill set. It's relatively simple, right? It's almost like pointing a light at a thing and picking up the scan. Of course, right, there's more intricacies into it, like, markers and colors of the material, reflectivity, how far you shoot things gives you better scans, and then also adjusting, making sure you got the scope of what you want to scan to get what you need done, right? You don't need a perfect scan of stuff because you're going to get stuck, right? Keeping scanning,
Yeah.
but you got to know that balance, like, okay, this is my final objective with the scan. Let me make sure to figure out I need this and this and this. And another thing is like figuring out how you want to scan all those parts, because you can't scan it usually all together. So how to separate the scans and then mesh it back together again to achieve your objective of whatever you're trying to do. I think the scanning side is not super
I mean,
difficult.
it's true. Like we had zero experience with 3D scanning before we got that first Morocco scanner all in one, and I think we picked it up pretty
Yeah, I
quickly.
mean, we did the whole headers.
Yeah,
with
that's really what helped us design and work on the headers, and it was really our first time ever using that type of technology. So it just shows that you just do it, learn along the way, and it's pretty easy to get.
I think as well, just at the enthusiast level now, I mean, it probably was only 5 years ago where for a worthwhile scanner, you were probably looking in the vicinity of 5K USD plus, probably more likely 10K USD. Now we've got a range of options that are sort of in that sub 2000 USD price point, which at that point, obviously it's not chump change. It's not going to be sort of walking around money for most people, but it's a very powerful tool. You can leverage it on so many projects. So it is actually a really viable addition to most people's toolbox.
Yeah, I mean the amount of possibilities it unlocks is it's astounding, right? Once you're able to put this thing into the computer, right? Then there's the second half, which we haven't talked about yet, is the CAD side, which I think I have a little more reservations on about simplicity of that. But the scanning side really does allow you to take your design to a high level, right? Versus like the headers was a good example. We 3D scanned the whole thing and CAD'd it in CAD, and we're able to get angles down to the degree. But then we also printed, the like one level below is like printing those little pucks or
Lego sets and fabrication.
yeah, and like trying to jig up the header that way, and just the amount of, I don't know, obscurity of doing it and the difficulty. It's just kind of crazy how you can progress the design to such an advanced state with 3D scanning, right? So it's a valuable tool.
If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high-performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code PODCAST500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. We'll jump into this header design because at the moment a lot of people are probably thinking, what on earth are you talking about? We'll get into that, so that's fine. But just a note on that while we're talking about it here is I don't know how you would design a 5-into-1 header per bank of cylinders with such tight room, or at least from what I saw, not a lot of space, manually without the technology you used, and still come close to an equal length design that's going to actually make sense. So basically what I'm saying here is I think it's unlocking possibilities that would not be something you could do using existing technology. So it is genuinely a game changer. On that note, before we move on from the scanner though, this it's a RevoPoint product that you're using, correct?
Yeah.
So this is, you mentioned all-in-one. So traditionally in the scanners we've got at work, or most of them, you need to essentially connect that to a pretty powerful PC. So it's not just the cost of the scanner, it's the PC, the graphics card, etc. that you need. So can you kind of explain the difference with these all-in-one products and how they work?
Yeah, that was the first product we used, and it's called the Morocco. It's basically an all-in-one 3D scanner. So it has the processor technology, or the capability within the scanner. It's got a screen on the scanner, so you can basically go from the scan to like a final mesh product all within the unit, and then you just transfer it to the computer and you have your mesh, right? And it's very I wouldn't
User
say it's the
friendly.
most accurate, right? It's definitely not. You're not going to get like the highest level of scan, but again, for something like what we were going for, it worked out great, right? And
You don't need precision down to point one of a millimeter.
yeah, exactly. And I think one of the better things about these scanners, especially nowadays, is that you don't really have to mess with any of the settings, right? When you think on 3D scanning, I think most people, even 3D printing to that point, they think you have to start messing with like the settings. You got to know, oh, what am I working with? Like these products come basically tuned for you to just start.
Just making it easier for the end user. You don't need a PhD in 3D scanning.
Exactly. And people go down that rabbit hole a lot, but I think that's one of the biggest enablers, right? Obviously, besides cost, it's just they're very user friendly. They're set up for beginners, basically, and we were.
All right. Well, I mean, if you can make it work, I think that's kudos to the product. It's obviously meeting that target market. All right. So obviously, as we discussed, then hand in hand, this goes with CAD and Jack, as you mentioned, maybe a slightly higher barrier to entry, not necessarily price point if you're using Autodesk Fusion. Essentially, you can use that for free as a home enthusiast, but the skill set needed. So is this a case of needs must? Basically, you had a requirement to master CAD, so hence you had to do it?
Yeah, so for me, I mean, the CAD takes a lot of practice. It's a different, I think, thought process too than usual if you want to do parts at a higher level instead of blocky type of parts. But the way I learned it was actually in college through Formula SAE. We were responsible for a certain part of the car, and so I did a lot of the design work for the gearbox in that. So I was in SolidWorks doing a lot of stuff there, and just through personal projects that I've built up the CAD ability. I don't think, I think there's a little bit of a difficulty in just seeing the problem and being able to do it in CAD. You have to fumble through it. There's a lot of tools. There's a lot of, I don't even know how to do surfacing really in CAD, like surface modeling. I only know kind of doing blocks and parts, and so it's a whole realm, and it can be very difficult. I think you can fumble through it, but you have to continue and just try to, again, hit that final objective that you're going after. You might have to make compromises, but build up that skill set as you continue to do more and more projects. Don't let it bring you down. I think it takes a little more.
Yeah, I think that's a fair comment. Now that you're out of college, are you still using SolidWorks, given that is a fairly expensive paid license, or if you transition across to Fusion, is there a problem transitioning if you were to go from one to the other?
I've used CATIA at work before, and I use SolidWorks still. I prefer it. It's what I learned in college, so I do see a difficulty switching. It's a different toolbox, but all the same tools, but it does bring a certain difficulty to
You
it.
kind of have to relearn how to even model the parts depending on the software.
Yeah,
So
definitely with those two.
yeah, I've actually tried Fusion 360 because you said it was free, and a while back I just wanted to see how good it would transfer. Because I also learned SolidWorks in college. That's That's what I use as well. And it took me a while to get used to Fusion 360 just because of, just coming from SolidWorks.
Of course, yeah. I think what you said there, same tools, but yeah, obviously there's a different way of utilizing them with any software. I can say that from our own CAD course, the skills can transition across between the different products. I think probably it's fair to say that for most of the home enthusiasts, Fusion probably is still the lowest hanging fruit. But essentially, takeaway from this is you can work in any CAD package and probably get results. It's going to be a bit of a learning curve getting there. In terms of the third part of this trifecta, of course, is 3D printing. And again, another technology that's just been a game changer. I wish I'd had access to this back when I was building my drag car, but probably the technology probably almost didn't exist. No, I know it did, but would have been at the probably $100,000 plus vicinity for these printers. I guess for someone listening to this podcast who's thinking they don't need a 3D printer, can you give us some use cases of how you've used it more than you ever thought?
Sure. I mean, I think like we've used 3D printing a lot throughout this build, right? And it's not to say that maybe we couldn't have gotten to this point without the 3D printer, but I think it would have taken a lot longer and also a lot more money, right? For us, the biggest benefit of 3D printing was prototyping. I mean, we did prototyping from the actual intake, not just the pipes, but the intake itself. We 3D printed entirely, a bunch of revisions over and over before actually cutting the parts and welding it together, right? That was the first big, I think, project for us with 3D printing. Headers was a big one, right? We 3D printed everything before cutting any pipes because I think contrary to popular belief, we're both very cheap. We try and do things as budget as possible. So we're very cost conscious and we don't want to start cutting metal before we have to. So that I think that's been like, and then the intake, the video we just did, I mean, we must have 3D printed a week straight just to make sure that things were fitting perfectly, and it just saves so much time, and money. And again, the tools are now, at least 3D printing especially, you can get a good 3D printing for very, very cheap. And again, you don't really have to mess with any settings. You just print your part and go.
Oh, I'm interested to get your take on this. I think you guys use a bamboo.
Yeah, we just used it for this video, right?
But you've got a Creality as well?
Yeah, we both have.
Okay. So we started back when we employed Connor was sort of around COVID. And back then we bought our Creality 3D printer, which was our first one. And it works. And you can 3D print a part, but its reliability is possibly questionable, and I kind of see the guys spending about as much time leveling the bed and discarding failed prints as I see parts actually coming off that printer.
Absolutely.
So it was a couple of years ago, I think we kind of saw sense and ponied up for the bamboo, which is a far more expensive product. But I mean, you see the two side by side, you can see where the money goes. But that seems more like, how I'd put it, as the Creality is maybe perfect for the person who's a bit of a 3D printing nerd and really wants to build the 3D printer. The bamboo is more for someone who wants to send something to print and get a finished product reliably every time. Am I right on that?
Yeah, I'd say that's true. Yeah. I mean, that's one thing we talked about in the video, right? Like I have, I think the most basic Creality. I bought mine 8 years ago is the Ender 3. Pretty sure that's like the second or first one they came out with. I mean, that's the biggest problem I have. It's always bed leveling. I went through this issue for the longest time where it just wasn't print. It would get clogged mid-print. The most annoying thing. I almost quit. I almost threw it out.
I mean, you just kept swapping all the parts. You ended up with a new printer.
I replaced basically everything, and it turns out
you could have bought a new printer.
I really could have, yeah. But I was, I liked my printer, so I just wanted to get it to work. I was detached.
He's a little 3D nerd, 3D printing nerd here.
No, but funny enough, the only thing I had to do was switch slicer software for some reason, and that fixed it. I'm still can't imagine. Maybe I messed with some settings, which again goes back to the point where these printers are really, you don't have to mess with many of the settings. I was probably messing in there just.
Well, I mean, that's the real beauty of the Bamboo Labs, right? Like, put the part in, click, and it's like the quality is almost, it's night and day compared to that, and the ease and the speed
Speed was a big thing, right? Because like you guys have a creality that takes, especially if you want to avoid failures, you kind of have to cut back on the speed a little bit.
Yeah, I mean, there's compromises with everything, and the compromise with the bamboo was, I mean, back when we bought ours, I think, we were maybe circa $5,000 versus $1,000 for the creality. They're in a different league price wise, and that's obviously not to say that you can't get a good result with a cheaper printer, but you obviously also need to have your eyes open when you're going into this, understand what you're going to be getting and what those compromises may look like. You've talked about the use of that printer for prototyping, and clearly that's a very, very powerful use of it. They can, however, be also used for final parts, and we're getting a little out of order here because we still haven't talked about the car or this engine, but we will get there. The intake system, that essentially the 3D print formed the basis of a final part, didn't it?
Yep.
So how does that work, and are there any considerations around the material that you're using for the print that is going to make it viable for a production part?
Yeah, I mean, so really in the engine bay or with the car, heat is probably the biggest thing. Heat, and then like corrosive with fuel, or compatibility with fuel and different oils and stuff. So yeah, the intake piping, right? We printed that out of ASA carbon fiber infused. Really, we didn't need the strength of carbon fiber because what we ended up doing was coating it with carbon fiber chop and epoxying it. So that was really our core was the 3D print. So we just needed good stability at temperature, good, some decent structure for us to be able to sand and do all the stuff we need to. But then also incorporate like flanges we use like HD Vangeon clamps on the ends. So we were able to print all of that in there. So we needed good dimensional, stability. So like PLA is the most generic, cheap, filament, but that doesn't really withstand well in the engine bay due to temperature. So it'll soften and warp. But the ASA and ABS, is much more compatible, more high tolerance to that. So that's what we printed all that stuff out of. And like we've used a lot of finished parts out of it, like a lot of bracketry to hold fuel lines, fuel rails, brake lines, fuel filter. We printed all of that out of ASA or ABS? ABS. Yeah. And those are our finished parts on the car. So, I mean, it does produce functional parts that you're able to use. And you could do whatever you want with it, right? I want to clip this one here and here and here. All right.
I think that's the power I see with it, is just being able to come up with bespoke one-off solutions to problems that you couldn't solve with off-the-shelf parts that already exist. Hence giving a much cleaner, more professional finished look to a project. So yeah, huge benefit. Just in terms of those materials you mentioned, again, just to give some reference, could you give us like percentage wise, what you'd pay more for maybe the ASA and ABS versus PLA?
Yeah, US dollars, right? So a roll of PLA is maybe $30. When you step up to ABS, it's maybe 33. ASA, maybe 35. And then we start getting to the carbon filaments, add a couple more dollars. So it's not like, 10s or 20s or 30s. It's like, a couple percent from the price.
It does require, a different printer capability though, right?
Yeah.
Higher temperature print heads, carbon fiber, especially hardened print, nozzles and that stuff.
Yeah.
So there's other cost factors.
Yeah, there's definitely levels, but ABS is still a perfectly good material to use even for finished products, and that is basically, I'd say, on par with PLA.
Okay, great. While we're talking about 3D printing technology, I'm interested if you've sort of considered going down the path of adding a resin printer to your lineup at this stage.
Yeah, that's a good one. I mean, because resin printing really gives you high fidelity quality parts. That to me is the biggest allure of it, is like being able to give nice surface finish. But I thought the big drawback is bed size and what do you call it, UV
Curing,
curing it. But it's a good question.
We haven't really talked about it. I guess I'd be interested in seeing how we can implement that into the channel at some point, but
definitely a far superior. And I'm talking here like I'm an expert on 3D printing, which I'm absolutely not. That's why we employ Connor. But I also, because I'm surrounded by this stuff, I kind of almost know enough to be dangerous. And our resin printer, you're absolutely right. The bed size, the print size is quite limiting The surface finish, amazing. You give it to someone and they wouldn't know necessarily they've been 3D printed. But then when you couple that with the limited bed size, and as soon as you're sort of talking surface finish, that kind of goes out the window when you start having to actually join multiple pieces together in order to get to the finished product size. But it's a very interesting technology, and just another one that sort of got to that price point where it's semi-affordable to the enthusiast market. I think we should probably get started with the podcast now.
All right, sounds good.
Start talking about what your channel's best known for, which of course is the 4-valve V10 modular Ford-based engine. Before we dive deep into that, though, your channel, Build It Yourself. Can you give us a bit of a rundown on how that came to be around documenting this build?
So I think the name was kind of like we were just joking around, basically. But in terms of how we got started with the build, it was we're basically neighbors at this point, and we started working on this cheap Mustang that we wanted to learn how to drift on. And it's got this old 302. It still runs, still drives, but I don't know how, but it still does.
Knocks like crazy.
Yeah. Yeah, we started running into some issues with the transmission. Blew up, I think twice now. In one of those instances, we realized, the block is cracked, right?
Yeah, it looked like it froze.
Right.
Cracked the block.
And so that one of those things is like we started joking around about what we should do with the car. And I think I threw in that, we should V10 swap it. But just, it was so long ago. We've been talking about this for a while. I don't even remember why I brought up a V10, but I did. And then he kind of went in, being Jack, of course, he went into this rabbit hole of, maybe we should make it, high-revving. It should be a 4-valve. And then,
Yeah, sound was the big thing to me. I wanted it. I thought the V10s could sound cool, but I just never found one, a Ford one, that was like, wow, this sounds great. So I was like, well, can we rev this thing? Like, it's even fire, right? It has all of the ingredients. Can we make this thing rev?
Yeah, I think that V10 on its own is not enough. And I mean, the Dodge Viper is probably a classic example. I don't have much experience with those, but what I've heard, they definitely don't sound like a Formula One car to me.
They do not.
Yeah,
that's for sure.
They don't have that even fire, right? Sound like LFA. Porsche Carrera's close to perfect even fire, but not quite. But still, it's that sound on F1 car V10 era. They rev so high that it almost sounds even fire. It has that unique sound, even though it's not ideal, or most of them are not a perfect even fire engine. But
can you give us a quick explanation of what even fire versus odd fire means? Because that's quite a key part here, particularly with the fact the Viper V10 is an odd fire.
Correct. So the even fire means, between every cylinder firing event, there's an even number of degrees happening of crank rotation between each one. So for a V10, you take, there's 2 cycles to the crank for the power stroke, or 1 full power stroke. So, you divide that. So it's 72 degrees on a V10.
So 720 degrees, 2 full revolutions for a full engine cycle. Divide that by the number of cylinders. We have 72 degrees.
Correct. So that gives you the even, if you hit that number, it's even fire. A V8, same thing. If it's 8, 720 divided by 8 is 90 degrees. So
this comes down into the bank angle in order to get that even number of degrees between firing.
Correct. So yeah, it is dependent on bank angle, but there's a magic recipe that you can fake bank angle by split pin crank, moving the crankshaft journals of adjacent banks relative to each other. So that's your split pin. So for example, LFA is a perfect even fire. It's a 72 degree bank angle with same pins, similar pin or straight pin. So that gives you an even fire from the beginning. The V10 Ford is a 90 degree bank angle, but they move the pins relative to each other 18 degrees to allow it to have that 72 distribution. A Viper is a 90 degree bank, but the pin is shared. And then you get, I don't know if I could call it off my head, is 90 and 45, or it's a weird number between. So you have a big space, small space, big space, small space between the firing. So it gives you a rumbly sound.
And you'll hear that. There's the other complexity with that. I think these days it's probably pretty easy to do, but back many, many years ago, I tuned a Dodge Viper that had a supercharger fitted to it. And back then there were a limited number of ECUs that could actually handle an odd fire engine, because it's quite unique. There's not that many out there in the wilderness, correct?
Yeah. And it does, it's more processing power. I think, like Ford, we just got to see the car one time, Ford, when they did their V10. It was the original V10 in a Mustang, the Boss 351, that had a shared pin on a 90 degree, and they had to run two separate computers because they couldn't figure out how to get that, change in angle with one computer. So
Coming back to that split pin crank design, I can only assume that would be sort of a sacrifice in terms of strength versus a common pin or shared pin.
I mean, yeah, I mean, right. If you had the choice between a shared pin and a split pin, I think most people would go with the shared pin. But and that was one of the biggest, I think, critics we got when we
when we
started this
started,
project. People were basically saying, "Oh, this is never going to work. The split pin is where you're going to fail or whatever," right? Even though we actually were concerned about this initially, so we did a little bit of research, and there really isn't any cases out there where people have split their crank on the Ford V10.
The design, it's an engine that I'm definitely far from familiar with, but again, just from sort of having a bit of a deep dive on your YouTube channel, this is a two-valve truck engine that the V10 was designed for, so performance in terms of high power at high RPM just wasn't a consideration, so the split pin would have been a no-brainer.
Yeah,
correct.
yeah,
Yeah,
that's right.
5,500 RPM red line or something around there. So it didn't really, not designed for high RPM. When Ford did their four valve, they made it a shared pin. So, I don't know why exactly they decided to do that, but there are other notable split pins I do want to bring up is like, the 5.0 Gallardo that has a V10. The pre-LP, they call them, that was a split pin V10. Then they went to the Audi designed V10 that was a common pin. And then even like GM V6s are split pin to get a 90 degree V6 to have an even fire. And those are robust. Everyone loves those guys. So we thought there was a little bit of hearsay of saying, oh, a split pin is going to break. One of the biggest component or proponents of that I saw was like a twin turbo Excursion making like 700 horsepower and 1,100 foot-pounds of torque. And he hasn't split his pin, but so.
I think the great thing with the internet is you are always going to be opening yourselves up for very aggressive comments made with a lot of sort of assertion about things that person has not personally experienced at all. The internet experts will absolutely tell you what will go wrong with no personal experience. So, yeah, sure. There's some engineering background to why it would be an inferior design, but the question is, what was the safety margin built into that component to start with, and are you going to be anywhere near it? We talked before starting recording that it's also a factory forged crank, so we weren't dealing with a cast crank that could be more problematic. And I think people really don't give credit to just how over-engineered a lot of the OE parts are. Back in my drag racing days, we used to use a billet crankshaft, and at one point I cracked that crankshaft, couldn't get hold of another one. They're hugely expensive. Put a $1,100 factory 4G63 crank in this engine, designed for 7,500 RPM, 300 horsepower. We're making 1,200 at the wheels and 11,000 RPM. It lasted just as well as the billet crank. So,
Wow.
I mean, I don't think too many people on face value would assume that factory component could go to that level. All right, I guess with this engine, the key to it is not so much the truck bottom end, the truck V10. It's really in the heads, and that's where the trickiness comes in. So there is no off-the-shelf Ford 4-valve double overhead cam cylinder head for a V10 that you could buy, correct?
That's right. Yeah, I mean, Ford just made a couple prototypes throughout the years, but nothing that anyone could get their hands on.
They came with 2-valve and 3-valve. So that was, first iteration was 2-valve, and then it went to 3-valve. They also produced 2-valve with it to get more power with the 3-valve. So that was their all Ford's offerings are.
Was there ever a consideration that either of those 2 or 3 valve cylinder head designs would be viable for the project? Because that's going to be easy.
We've actually talked about that a lot, like, okay, we've built this thing. Obviously it was a passion project and it's just interesting to build this, but could we get something with similar results with a 2 valve, or a 3 valve? I think as far as like what is available aftermarket for stuff like that, it's probably still not much, certainly more than the 4 valve, but obviously you don't have to deal with welded heads and
Custom cams.
custom cams. So in that sense, it would be a much more attainable build, I think, a much easier build.
No doubt at all.
I would think you could achieve within like 90% of what, a 4 valve head. Or there's a benchmark already too, right? You have 4 valve, 3 valve, 2 valve, 4.6 mod motors. So just look at what a 2 valve max effort does, a 3 valve max effort, a 4 valve max effort, compare them.
You kind of can extrapolate that out and you know where you're going to be.
Yeah,
Right.
yeah. You can see if it's worth it.
People build 2 valve
Yeah.
motors, but V8s even today, right? Even though you have 4 valves. So I think it's kind of, I think for us, it was like, oh, well, this is, again, going back to, it's kind of like a tribute engine, and like, it's part of the challenge, I guess, right? Can we build these heads?
So this is where the challenge comes in, essentially taking 2 4-valve heads per bank, cutting them not quite in half, and then welding them together. I distinctly remember a story from my old workshop back sort of 15 plus years ago now, and a guy walked in the door, young guy who had some champagne dreams maybe in a beer budget, and it was always the story of people, rather than walking the path that's well trodden with proven results, where you know the combination, it's going to probably not break the internet, but it's going to get the job done for a reasonable cost. Then there's the people who want to do something because it's different, which I guess kind of covers you guys. We'll get back to that anyway. And this guy walked in and said, I can't remember the engine he wanted to use now, but essentially it was taking I think, let's call it a 2JZ, and just cutting 2 cylinders off the back of it and welding it back together. And he said, just cut and shut it, the block. Like that was a thing. And we're looking at him like, what planet are you from? No, that's a terrible idea. Yet here we are, and turns out that cutting and shutting a cylinder head's a thing. All right, I mean, let's start with the obvious sort of challenges that are involved with welding 2 heads together and all of the things that you have to get right to not just have an expensive oil and water sprinkler system.
Sure.
I mean, yeah, it's overhead cam engine. So people have done stuff with push rod engines, right? I think a big trend was like Ford inline 300s, inline 6s. They'll put LS heads. A old story of like or engine that they built was Cleveland 351 heads on a Ford inline 6 too. So people have been cutting up heads and welding them onto stuff, but
they don't have to worry about coolant.
Yeah,
heads, right?
yeah, we have oil passages, coolant, and the cam bores lined up, right? Those were the big.
Those are the big 3.
Yeah,
right?
The big things. So the oil passages was relatively simple in terms of they kind of just have these 2 line drilled bores in there, so you can weld and put a cap over it, weld up the cap. That's kind of how we did that task. But getting the cam bores to line up, that was another problem, and it also compounded. So the heads we're using are from an Aviator, Ford or Lincoln Aviator. They're the same as the Cobra heads. They're the 4 valve heads that Ford had, and it just so happened to add confusion to us. We got a set of heads from an Aviator that had a rebuilt engine, so that had a decked surface already.
And we didn't know until I think well into the welding process, right?
Yeah, it was like, why are these never lining up? And the way we were kind of lining them up was trying to put a cam core or a cam inside of there and spinning it using like a
diff axle or a marker, what they use for that check backlash or the pattern.
Yeah, so putting that on the cams bores and spinning it, and then shimming it with with
Aluminum foil.
aluminum foil to get it all right, and then torquing it down onto a block because we didn't have a big piece of metal to bolt all this stuff to. So we're using the block to tighten it down, and then just welding back and forth and checking the cams and trying to guess like, oh, it's binding a little this way. Let's heat up this side.
Yeah, I mean, it was a learning experience, right? I think doing it, we weren't really sure if it was going to work.
Well, I guess up until now, there wasn't a YouTube video you could watch about how to weld two cylinder heads together.
Oh no, absolutely not. Yeah,
Unfortunately,
Yeah.
yes, we could have
Right.
avoided mistakes.
yeah, and you know, it kind of goes back to these are off the shelf parts. So like Jack said, we went to a junkyard, picked up these heads. Even the engine itself was from a junkyard. So if it failed, you know, we were out a couple $100, like not a big deal, right? But yeah, and the biggest challenge I think for that was the cooling system, right? Is before welding it together, we had some time to think about one, how do we attach the heads together, right? Do they need some kind of like interface? Like, do we have to machine the heads so that they kind of interlock together to add more support? Where do we cut them? And then obviously, how do we prevent the oil and coolant from mixing because we can't weld inside once they're together. So, you know, I think the blocking off the coolant passages, it kind of is not the best way if you're going to do it, you know, I think, or if you want to do it the right way. But for us, it was just the easiest path. And I think the idea was, well, we can cool the heads or both halves individually, right? Ford had coolant inlets on both sides of the heads. So the cooling part, yeah, it's not ideal, but I think we were fairly confident that we could cool the heads, even though the block or the passages between the two halves were blocked. I think so far we haven't had, I mean, granted, we haven't really driven the car much, but we really haven't had any issues with overheating.
So it's obviously it's worked. I guess beyond the obvious that you've just mentioned, not ending up with oil and water leaks, you've got the damage or distortion that the amount of heat you've got to pour into that casting. It's a big old heat sink. So the amount of heat that you've got to put into that with the torch is pretty significant. And that does a whole lot of ugly things to a casting, making it move around. The other aspect as well is what it does to the heat treatment on the deck surface of the head, because that's heat treated to harden it, essentially to help with head gasket integrity, head gasket sealing. So talk us through sort of the problems that involves. I'm assuming with the deck surface, once you've welded, that's as simple as taking it to any machine shop and just getting them to surface the head. But what other issues did crop up with that? Is the hardening a real problem, or is it just irrelevant?
For us, it has been, let's say, irrelevant in terms of we haven't had an issue with any bypass or gas bypassing or going into the cooling system or anything. With terms of, the head deck surface, we were able to take it to the machine shop. It needed a few cuts, they said, but it really didn't hurt us too much. With an overhead cam engine, it can affect your timing, your cam timing, but we fully degreed the engine, so we were able to compensate for whatever we needed to via, cam timing with that. But surface hardness, I don't think we really had. There was no issue. We haven't pulled the head off. Oh no, we did torque the head. We've torqued the head and pulled it back off, but not after any run time, just like while we're setting it on and off and doing work. And I don't remember seeing any depressions near the weld or surface or anything.
It's not something I've personally had experience with, but of course when you've got an engine that's had a blown head gasket, one of the things the machine shop will typically do is check the surface hardness of the head. And, I don't know, maybe this would become a problem if you're running a pair of turbos and north of 1200 horsepower when the cylinder pressure is much higher. So maybe at the level you're at, it's just not a concern.
Yeah.
Where you welded that head on the deck surface as well was essentially between two of the cylinders, quite close proximity to the valves on each side. Was there any distortion of the valve seats due to the heat? Is that something that required attention?
I mean, we got a full valve job at the head shop, but we, at least from the machinist, he didn't specifically call out any complications or any issues that he saw from machining the head. So
I mean, we reused all the seats, which is 4-valve heads are known to have poor exhaust seat retention.
they dropped a lot.
Yeah, the dropping exhaust valve seats.
Well, that's something to look forward to.
Yeah, yeah. So one of the recommendations is that if they don't spin while you're cutting new seats, you don't really need to change them necessarily. I mean, for us, we have like 13-to-1 compression revving to 8,000 RPM. So we probably should have done it. But again, like we said, we're cost conscious. So we didn't opt to do that. And they didn't have any issues with any of the seats spinning. So
Watch this space.
yeah,
Right. Yeah.
knock on wood.
All right, getting to the real core issue though, line honing or line boring the cam journal, and we need this cam journal to be perfectly on size and also perfectly aligned. Otherwise, you're going to have a laundry list of problems with your camshafts and reliability. So, again, from watching your videos, no machine shop really seemed interested in taking this job on, which surprised me.
Yeah, I mean, I don't think we really wanted to go that route, right? We actually reached out to a lot of shops, but no one would take on the job. One is a custom head, so it's not like a common, I guess, setup. And yeah, I guess just, we don't really know really any good machinist or really a shop that was set up for that. So yeah, we kind of were forced into doing it ourselves in a way, which is kind of the theme of the build or the channel anyways. But yeah, I mean, it wasn't really our first option.
Yeah, it was a lot of going back and forth, like, oh, we're done. No, we need to try to do something, right?
Yeah.
See if it works. And so we were like researching, they make, line boring bars for 2-valve, 3-valve heads to bore out the thing. So we thought maybe we could replicate this thing and do it ourselves.
Yeah. I mean, that was another, and it's like, I think what helped us in a way is that, yeah, like you said, there was this tool. I don't think it's available anymore, but there used to be back in the day a tool that you basically plug to a drill and you just line board your heads with, which seems like probably wouldn't be the best results, right? Like with your drill, you don't have a lot of control. How are you're not even measuring what you're doing. So that kind of gave us a little bit of confidence. But, I happened to have a lathe at home. So we kind of just rigged up this setup and we were going to use cam bearings. So I think, at least in my head, as long as we got the bores to line up and we were able to get close to the spec that was required for the cam bores, we were probably going to be okay. The cams or the bearings can wear a little bit unevenly and kind of even out ideally.
I think one of the benefits with that, as well as the clearance on a cam bearing or a cam journal, is typically not quite as mission critical as the likes of a main bearing or a conrod bearing. So maybe you got a little bit more leniency. I'm not too sure, never having done this. Obviously, it's working. So once you've got that done, the next obvious problem is a camshaft for this thing, because you can't buy an off-the-shelf set of cams for a Ford V10. Is it difficult to find a cam manufacturer that's interested in doing this?
I mean, that was, I think that was another perfect example of we're kind of forced into this doing it ourselves situation, because I won't say there isn't.
Yeah, no, there is.
We found companies that were willing to make the cores for us, even the full
make the
camshaft.
full cams, right?
But again, it was either they couldn't do it, or if they could do it, it was going to be significant amount of money, right? They either had minimum order quantities that we didn't need, or it was just they're quoting themselves out because it was just something that no normal person would ever, pay.
They don't want the job, so you chuck a stupidly large number out there, and then if the customer accepts it, well, at least you're going to make a worthwhile amount of money for your troubles.
Right. Yeah.
So what was the solution then?
Well, we ended up basically. So we designed we have the 2-valve camshafts that came with the engine that we pulled. So we ended up reverse engineering a set of 4-valve cams, and we catted cores. We were able to get a machine shop to make them, and we did work with a real company to grind the final parts. Bullet Racing, they machined the finished cams for us.
Yeah.
So it was That was a fun night actually, because we kind of
That was a fun
it was one of the times where we actually had to do like math, figure out the firing order of this engine, and like so. But yeah, that's basically what it took. Just
We actually had the firing order backwards the night before we sent out the file.
yeah,
It's like, wait a second, why are these
measure twice, cut once. That's a big
why are these
lesson.
loads not making sense, dude?
That would have been a very expensive fail.
Absolutely.
Yeah, there's a lot of luck in what we've done.
Sometimes it's better to be lucky than good. I guess one obvious question here, and I think the answer is probably self-explanatory, but still I'll ask it. Why did you not consider, or did you consider any of the other available V10s? You've already mentioned the Gallardo. We've talked about the Viper, maybe not the most ideal solution. I think Audi also make a V10 that's similar in architecture to the Lamborghini V10, but none of the parts are interchangeable. Those are relatively cheap. So there are other options out there, but you guys seem to be Ford through and through. Was that the sort of decider?
Yeah, I mean, I'd say that's definitely part of it. Again, it kind of has that historical, nostalgic type of tie to it, but also, and it's something we touched on a couple of our videos. There's tons of Ford V10s at junkyards that you can get for close to nothing. Obviously, a Viper engine is significantly more expensive. You're not going to find that at a junkyard. Same with the Audi V10s. You probably have to get that from eBay or some.
So you're going from a few $100s to potentially a few $1,000s or more.
Yeah, thousands, right? And I think one of the benefits of this motor is that it's part of the modular family. So pistons, rods, those are all cam or bearings. They're off the shelf because they're the same as the V8s. So in terms of custom parts, even though we didn't go with stock components, you can buy off the shelf bottom end parts.
Yeah, that definitely eases the financial pain when you're building an engine. Always much more expensive when you're working with an engine where there's no aftermarket support and everything has to be one-off customs. You sort of can easily double the cost of your pistons and rods, for example.
Right, yeah.
Yeah, there's also the challenge of, I mean, sure, the Ford side of it, but also like we were seeing people were trying to tackle this, make a 4-valve V10, and no one ever, was able to complete it. So that was like kind of the, what?
Let's see if we can do it.
Yeah, let's see if we can do this shit, right? Let's see what we got. Because it started, like I said, swapping it into the Mustang. So that's kind of where the Ford maybe started V10.
Yeah, I guess.
And like, well, maybe we can be the ones to hit this hit this project and see if we could do it.
I think there's something to be said for the content you can create as well. I mean, it's not going to be such compelling content picking up a Lamborghini V10 from eBay and making some engine mounts and adapting it into a chassis. Yeah, it'd be a cool result, but welding some cylinder heads up, that's not something you see every day.
Right. Yeah. So, I mean, I think the engine just definitely wasn't the easiest, project, but it's just it was a cool learning experience and it paid off, I think, because
and the even fireness of it was the sound that it should be capable of, right? There's those YouTube videos of the tuk, 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 the lights, right? And Ford V10 and LFA have the same tuk, tuk light sound. So like, man, this thing should make some sick noise.
So it should ideally sound pretty much like an LFA.
Correct. Where the other V10s, the Gallardos, the one I could think of that isn't even fire, BMW Viper, a Carrera, you're not going to get a Carrera engine anyway. So like, it's hard to get that sound in there.
All right, and jumping just a bit ahead, but we've talked about everything else with this engine, so we might as well talk about the results to date. Did you have a target for power and redline from the outset? I'm guessing you did, because everything you select for the engine is going to really be driven by that final result.
Yeah, I mean, one of the first texts about the engine that I sent to this guy was, can we rev it to 8,000 RPM? So for some reason,
it was locked in stone when he sent that text. So it's like, that's been the target since the very beginning.
Yeah,
naturally aspirated, 8,000 RPM.
which you achieved.
We did. We have almost 8,300 RPM. It hit at some red line point, I think, when I missed shift or something, but it did hit 83.
Perfect. Okay, and of course the big one. How much power does it make?
Yeah, right now
You got to 495 to the wheels.
Yeah, so 495 wheel.
We started running out of fuel at the dyno, so kind of had to stop there. Didn't meet our goal, so I think the plan is to revamp the fuel system a little bit more, and hopefully that'll get us all the way there.
That's no slouch though. And I mean, ultimately, while, let's not add up the number of hours of labor that you've both poured into it, but I can imagine, just the parts outlay would not be kind of bankrupting.
Yeah, it's. I mean, I'm here a lot.
I have absolutely no doubt. All right, the next part we need to talk about is the chassis that you chose to put this in. You talked about the Mustang, but it's not a Mustang. And when Brad, our podcast producer, first sort of told me about you guys and this Lincoln Continental, and I'm kind of thinking Entourage, 63, 64, I think that was, convertible, suicide doors, and I'm thinking, it's an interesting combination, but yeah, I'm down for this, but it's not that. It's not that Lincoln Continental. What model is it? Or what year is it?
It's a 2017 Lincoln Continental, so it's basically a different top hat from the Ford calls it the City 4 platform. So the Fusions, the Edge. Yeah, it's a front wheel drive based sedan, so all the good stuff,
On face value, that would not be the ideal candidate for a V10 rear wheel drive swap. What drove this decision?
Yeah, why don't you answer that one?
So, do you guys get that car in New Zealand at all? Did you guys?
Absolutely not. No.
Okay, all right. So I mean, you've probably seen it in pictures and videos maybe, but the car actually looks really nice. I think to me that's probably one of the biggest misses, I think, of Ford at the time, or Lincoln, because that car, you look at it, it really deserves a proper, engine, transmission, chassis setup. Granted, people are happy with, you can get the twin turbo V6, and that makes decent power.
400 horse,
right? So it's not like it's not capable, but it's not the sedan Grand Touring car that I think it should have been. So I had this, again, going back to the fact that I like to make Frankenstein builds in my head. This was something that one time I said, oh, you know what? I'd love to take one of these and swap GT350 drivetrain into it. So V8, 6-speed rear wheel drive. But that was always just I was never going to do it. It was just like, oh, that would be really cool. And then I'm still not sure how I convinced this guy to eventually go this route. But we found this car in Copart, and it just happened to be very cheap. It was wrecked in the front end, which is perfect because we were going to have to tear all that up anyways. And it so happened to have a Michigan title, and we're in Michigan.
Clean title,
yeah. Which means we can insure it, we can register it. I mean, it was kind of like everything kind of just came together, and we made a bid for it.
Sidebar here, and really not relevant, but I hear this clean title pop up all the time. What is a dirty title? How does that happen? What's the relevance of this clean title?
Yeah, so I guess I don't know what's like a good example on that side of the world, but here we have salvage title, clean title, rebuilt title, right? And it just ultimately depends on, like, a salvage title is basically a car that an insurance company has written off.
So if you've got a salvage title vehicle, does that mean that you couldn't legally put that back on the road? It's basically a parts car, or you could turn it into a race car.
Yeah, you can put it back on the road, but you have to repair it and get it inspected to get it a branded or rebuilt title. And then you can register, at least in Michigan. Every state is a little different. So what I'm saying is for Michigan. But
so then you've got this rebuilt title hanging over it, though. So that's going to be visible when you go and sell it and will affect the value of the car.
Exactly. Correct. Yeah. And for what we're doing, we couldn't do this work and get a rebranded title because there's no, worthiness. So it would be only a car you can't register in.
Okay. No, cool. I've got all that now understood. Thanks for the clarification. All right, so you've got this crash car. How involved is it to convert it to rear-wheel drive and then fit this V10 into it?
I mean, so we start with the rear end, and like, Diego said, it's based on the Fusion. So someone else has actually rear wheel drive swapped the Fusion. His name's Matt Sopa. So he built a 5-liter Mustang and a Fusion, a pretty sick drift car that he made. So there was some precedent in what it was going to take, kind of, or what needed to get done. So the rear was almost bolt-in relative to what we do is bolt-in. We just had to cut the front mounts off and move them around, but the rear parts of the mounts just bolted in to the stock subframe. The front end took a whole development, or we had to make brackets to come down to the subframe because the front wheel drive subframe is massive and supported by mounts at 4 corners. So that we had to cut everything all out and make new brackets and stuff. But I mean, it wasn't that hard.
Yeah, I mean, honestly, I think the hardest part was figuring out where everything needed to go for it to line up properly, right? Because we had the to fit the engine and transmission, so that we had to cut out the entire firewall and the transmission tunnel. Then trying to line up the wheel centers, the height of the engine, the subframe. We wanted to make sure the engine fit under the stock hood of the Continental, so that was definitely something we had to mess with. But yeah, it wasn't it was difficult, certainly, but again, it was something that you kind of just weld a couple brackets here, trial and error, and then once you have everything lined up, if you can weld and you can cut some metal, I think it's fairly attainable.
The sheet metal forming was a big thing, like making the firewall and the trans tunnel. I would say that was
I mean, you could probably go the very basic bare bones, right? Just weld a bunch of flat sheet metal panels and close the gap. We were trying to make it a little nicer, so we had to buy this bead rolling tool and learn how to bead roll. Honestly, we still can't really do straight, but it worked out okay.
Yeah, that bead rolling is harder than it looks, and then you see some of the really intricate panels that someone's rolled patterns into. I just can't do that.
They're artists.
Yeah,
artists.
We could never match the ends. If you look really closely, you'll see that the bead is like this.
But the bead rolling in those bigger metal panels as well is not just for aesthetic. It actually does do a lot to add stiffness to the panel, correct?
Yeah, definitely.
All right, let's talk a little bit more about the header and exhaust design, because I know that you guys went really sort of deep down a rabbit hole here on how the exhaust was going to affect what the engine sounded like. So can you give us maybe a sort of a quick physics lesson on how all of this works?
All right.
You're the sound guy. So.
All right. I mean, so yeah, the prime objective, with the headers was equal length, right? Because we want, again, it's an even fire engine. It's the even oscillating fire, right? So each bank fires sequentially, left, right. So the goal is making sure all those pulses get at the collector at exactly the same time and right next to each other. So we made sure the lengths were the same, right? Equal length. And then we had to package that in the engine bay, which required us to do the 3D scanning, a lot of CADing, a lot of the 3D printing parts, make sure it all fits. And yeah, we wanted to use 5-to-1 collectors. A lot of people were wanting 10-to-1 collectors, but just packaging a 10-to-1 system would be unpractical.
Yeah, that'd be a mission.
Correct. And it requires even longer runner lengths. So the runner lengths are selected for our target power RPM, right? That's 7,500 to 8,000 RPM. So, we have like a 30-inch long runner to target that horsepower goal. And then, so if you have a 10-to-1, you got to route it there. That kind of limits you on length. But so that was a goal. And we also used metal 3D printing too to make the collectors. So that was something that was fun to do. We made spiral collectors. The spiralness didn't really affect the sound, but it was a fun project to have that and integrate the V-band clamps and use spring, retainers on the collectors. So, making sure we got them all 5 together, sequentially firing so they're not bouncing around. So
you're actually going around in a circle.
Correct, and the collector around a circle. So that was the heart of making sure all those pulses were hit the collector. That was the first step. Then the part I think a lot of people miss is the rest of the exhaust system also matters. So in there, we were targeting equal length again for each bank, right? We were looking at LFA to see how because they're a front engine car with rear exhaust. One of the benefits of a rear engine car is you have a much shorter exhaust length. So it does affect the sound because your exhaust length is shorter, and the length of your exhaust, like an organ pipe, changes the sound.
I think that would be a part that a lot of people just wouldn't consider, the length of the actual exhaust system. Like you say, most people just forget about that part of it. It's the header design.
Yeah, it comes into play, and that's why the LFA was kind of like a key one. While this car sounds so great, the engine's in the front. How are they doing this, right? What are they kind of doing? So we modeled the exhaust system to kind of mimic that in terms of the banks are completely separate. A lot of people want an X pipe or some crossover,
Merge,
yeah, something in the center. So that's kind of like counterintuitive. But I think we do have a crossover. So that was the next thing, that the LFA has they merge them way back to far in the muffler, so way back in the car, right at the tips there. So we needed to bring ours together because the more pulses you can get to happen together, the higher the pitch is going to be, right? So if you had a V8 and you just had, true duals, you're only going to hear those 4 banks. But when you bring them together with like an X pipe, it increases that frequency. So we made sure to bring them together. And then the real key piece was we called the resonator chamber, right? So we sound analyzed different cars, the cars that we think sound great, right? LFA, Mazei's a 5-rotor, that thing sounds super sick.
Yeah. Formula One V10s.
Formula One V10s, right? The Carrera GT, and they all have that intrinsic, we calling it the 500 hertz frequency sound. That's the predominant sound of those cars. So the next question was, an exhaust system is like an organ, right? The length of the pipe does change how the frequencies resonate. So now how do we make an organ pipe in our exhaust system to target this 500 hertz? So we used a lot of chat GPT or AI and some like music or sound wave theories to choose this resonator, right? Stepping the diameter of the pipe introduces reflections in the exhaust pulses. So making sure we have enough step of area and the right volume of that, not volume, but area of length of that resonator chamber allowed us to target that frequency. So, I mean, every step of that exhaust system was with the intent of making sure we can try to, harness or get that LFA screech, that F1 sound.
I mean, from what I've heard, you've come pretty close. Like, that definitely has that Formula One V10 sound. So
that means a lot. Thank you.
Yeah, we were both surprised.
It's always great when you have a theory run through the theory and it actually pans out in reality. Have you sort of done an analysis of the final exhaust note to see where you sort of landed in that 500 hertz?
Yeah, it was actually very close. We put it as a little, I guess it was like the end credit of the exhaust video. But yeah, we actually analyzed one of the clips that we used in the video, and it was, you could see it. It was right there.
Perfect. I've always sort of thought that when it comes to exhaust manifold or exhaust design in general, I think on a naturally aspirated engine, forced induction's just a whole different animal. I kind of feel like there's obviously a lot of theory around the lengths, header diameters, steps in the header, etc., in order to target the power band that you want. And then there's kind of like a melding between the science and the art. And I mean, where this comes from, I remember a customer back in my old shop, and we had this combination. I think it was a Honda B series, and it was off-the-shelf parts, and it made good numbers. It was nothing earth-shattering. And this customer went to a manufacturer in the US who made this beautiful header system, and it was all designed by computer to be the right diameters, lengths, etc. And it lost 8 kilowatts or something, which for a B18C was a significant amount. So the guy's out of pocket thousands and thousands of dollars for this part that just didn't work as well. And you sort of think, well, ultimately, if you are trying to get the most out of this particular engine, or in your case, trying to design for a particular frequency, it might take several iterations, but refreshingly, it took one for you guys. So congratulations.
Thank you, thank you. We
Yeah.
do have a few things to tune with it, like it kind of bells. Just the way we made it, it was not as strong as it
Yeah,
should be
yeah.
on that
It's
resonator.
just a can, a super thin can,
Yeah.
and you can hear it ringing at very low RPMs.
But
So we got to address that still. I think we've gotten lucky.
yeah,
I
again,
think
it's
that's a big
another-
part of it. Not to say that we didn't try to do it, but like you said, I think most times you have to iterate and go through. So with exhaust, I say we got pretty lucky, and if anything, that's a testament of kind of what the engine is capable of, right? So the fact that we chose again this even fire V10, like the foundation was there. All it took was just that little extra push to extract that potential.
One more little anecdote on the sensitivity of a naturally aspirated engine to the exhaust design. And I may have actually told this story on the podcast, but everyone can just listen again if they've heard the story. I was tuning a Honda B18C drag car, and it was an all-motor design, and for simplicity and lightweight, the exhaust just came straight out the front bumper, which for my Dynapack hub dyno was a problem because it kind of pointed straight at the dyno. And we were there to update the ECU from something or other to, I think it was to a Motec. So none of the hardware on the engine changed. And anyway, I laid down some baseline runs on the existing ECU just to see where we were. And then we wired in the new ECU. And as part of setting the base timing with the timing light, I was sort of down pointing at the front crank pulley. But you've obviously got to have the engine running to do this. And the exhaust is kind of just blowing straight in my face, which on the nasty carcinogenic race fuel was not pleasant for me. So I had the genius idea of just tacking on a 45-degree bend. And I mean, I think this was, it must have been 3-inch at this point. So I just tacked it to the tip of the exhaust in 3 places. It wasn't fully welded and thought nothing of it, set the base timing. And because it now didn't point straight at my hub dyno, I tuned the car like that. And the entirety of the torque and power curves were different, and I was down, it wasn't an insignificant amount, I want to say maybe 8 or 10 horsepower as well. And of course I'm scratching my head thinking, what have I done differently? I mean, a naturally aspirated engine, there's only so many levers you have available to pull, and clearly we're not changing the cam timing, so it's literally ignition, fuel, and VTEC, but I don't even think that had VTEC. Finally, I thought, well, the only thing I've changed is tack on this 45-degree bend, cut that off, and we're away. So, and that just blew my mind. If I hadn't seen it with my own eyes, I would have never believed that it had that sensitivity.
Well, that's interesting because when we tuned the car, when we got the car ready for the dyno, we dynoed it with basically just open headers. Right, we had some little mufflers that we did for sound mostly, but we didn't have the full exhaust system. And when we finished the exhaust system, we noticed that the tune was way off. I mean, obviously the tuner did a good job because we test drove it after that, and it was good. I mean, he got the drivability. He obviously tuned the ignition, fuel, but we noticed that
it wouldn't idle.
It wasn't idling.
Yeah.
We had a hard time starting it when it was hot, which maybe that's not so much the tune. Maybe that's heat soaking the starter, but I was surprised that adding an exhaust system would have such a drastic effect on the tune itself.
It's always refreshing though when you add components, be it an exhaust system like that, or basically any modifications you put on your engine. What you're really hoping for when you start running that is that it's going to be lean, because if it's lean, that means that you've got more airflow through that engine. You've improved the volumetric efficiency, and straight away, like, right, I know when I get the fueling back right, we're going to be making more power. So that's kind of satisfying.
Unfortunately, it was the other way. We're too rich.
The worst, the worst. Okay.
Yeah.
Let's not talk too much more about that. I just wanted to sort of circle back to your collector, because I think this is another amazing way of leveraging all of this technology that we've been talking about so far. And it actually looks suspiciously like a collector that Connor designed and had printed for our 3D printing course. So Granted, guessing you haven't seen that, so maybe he copied you. It's even got the twist at the end to the V-band. So
He'll be getting a
I'm
letter.
going
That's
to
funny.
be hitting him up about that after this podcast. But where I'm going with this is traditionally that collector part is, if you're going to fabricate one, it's so labor intensive, and then getting access to be able to completely weld it, it's a lot of work. Versus what we can produce using CAD and 3D printing. Now, granted, 3D printing using a consumer grade sort of PLA or something like that, so it's not going to work, not going to last. Okay, we know we're not going to get there. Metal printing machines definitely still well outside the realms of what the enthusiast is going to be affording. Sort of, $50K minimum, probably $100K plus for something that's actually going to be worthwhile. But you can leverage businesses out there that will 3D print your parts. I'm interested, are you able to share with us sort of what the cost of each of those collectors ended up being?
Yeah, I mean, they were actually comparable to buying a collector. So I think they ended up being about $700 US dollars. If you price a 5-to-1 collector, it's like right there. And,
Perfect. That was what I was sort of hoping you were going to say, because the point of the conversation was you can now design a part that you can't buy off the shelf. You can incorporate design elements such as the sort of the twist that you've got in yours that would be difficult, maybe impossible to incorporate in a fabricated part. And yet you're ending up with a component that's also cost comparable. So I think that's a no-brainer, and I think a lot of people probably think that 3D printed metal is still prohibitively expensive, and it's just not. So it's another thing that people should be considering when it comes to what the correct process for a particular part of their car is going to be. All right, I wanted to talk a little bit more about the YouTube as a business. We didn't quite cover it, but obviously you've got this project which you could have absolutely done behind closed doors. YouTube is not easy and it's not fast. I kind of find anytime I'm doing something for YouTube, it's going to take me 5 times longer than if I was just to do that job normally. Why did you decide to document the process?
Yeah, we've talked about this because we disagree on why we did it, but I think at the end of the day, we just wanted to basically share the project with people because we thought it was interesting and people thought it was too, right? We saw that there were forum posts about starting something like this, but never actually came through. So it was just a way of showing the progress and seeing how far we could take it, right? Because again, I think when we started the project, we didn't really even know we were going to have a working engine or even working heads. So it could have been a very short-lived YouTube channel,
Well, you open yourself up to, how would I put it, maybe looking a little bit foolish as well. With there's no disrespect in trying something that's outrageously crazy and failing. I mean, that's how we learn. But of course, you open yourself up for a lot of negative comments as well. You got to have a pretty thick skin if you're on YouTube.
Yeah, that we learned that the very first video we had this guy. He was very adamant that the way we had the heads cut was basically proof that we were going to fail at everything. I don't know.
Still bothers him to today.
No, but I mean, it's every video basically. There's always something someone would have done differently, right? And that's just the way it is. And
it's not bad sometimes,
oh,
right?
absolutely,
Like you sometimes get good ideas.
Yeah, I would agree. There's a body of knowledge out there. Of course, we've got people watching our YouTube videos that are literal rocket scientists, and they're commenting with their experience, which I absolutely don't have. So yeah, I think it's important to have an open mind because there are a lot of great ideas, but there's also that vocal minority who like to basically tell you you're doing it wrong.
Yeah, this just comes with, I guess, the job. It's one of those things you can't take too seriously. I mean, we don't take it personal.
Except that one.
It's obviously hit a nerve, that one. What would you sort of say over the time you've been doing YouTube? What's kind of been the highlights for you, the best parts?
I mean, getting recognition, right? Like being able to talk to you. I've watched you for
years.
Yeah, forever. It's like, wow, what I've done in my garage is like I'm able to talk to Andre. It's
Yeah,
just
I
so
mean,
cool, like getting that recognition. It's really cool.
Just a guy, by the way, just a guy. It's interesting, actually. Before you came on my radar, I've got a friend who sort of occasionally will send me a picture on Messenger of someone on YouTube wearing an HPA t-shirt, and that was exactly what happened. And now that I've sort of started researching for this podcast, you're pretty good at wearing the HPA t-shirt, which we appreciate.
Oh yeah. Yeah, no, I mean, I think that was basically, I think, getting the not maybe not so much the recognition, but I think you see that obviously we're getting to see the car evolve and the engine, and it's just very gratifying to see it work, and then also seeing other people enjoying it as well, right? That's cool because it's if we all like, basically that's why we put it on YouTube.
All right, I guess we have to sort of follow that up with the negatives, and I think maybe we've got yours, Diego. But
No, I mean he still remembers the name. I'm just gonna put that out there.
Okay, I remember it only because I know it was a fake account.
They're always fake accounts. Yeah.
Yeah, but I mean, we know we definitely get a lot of maybe not so much negative comments. I think we get more negative comments about the music we use in our videos than the actual project, But there's there's definitely a lot of feedback, whether it's redundant because we already covered it. I think one thing I've noticed is a lot of people comment as soon as they see something in the video instead of waiting for the whole thing. It's like, well, I kind of did that at the end of the video, but all right. That's just been a recurring theme, I think.
I think there's people have short attention spans as well now. So your retention to the end of a video, you're going to get a lot of people fall off. So they comment prematurely on stuff that, as you say, you've kind of covered off anyway. That's the nature of the beast, I think. I do remember it's a recurring thing. I haven't seen it for a while, but we get a lot of very, very angry comments on our YouTube videos about my accent.
What?
And I get that. I have an accent. I come from New Zealand. I mean, accents are a thing. We all have them.
Sure.
I personally cannot change my accent. And while I understand that some people may not like it, why would you comment about something that is just an inherent feature of a nation that you can't change? So that's always been interesting. But when they get quite angry about it, quite heated about this accent that they're struggling to understand, I remember one of them in this heated argument he had, but he couldn't string a sentence together in English. So I'm like, there's a disconnect here that you're not seeing, perhaps.
He's just jealous of your well-spoken voice.
I don't know, but yeah, I mean, I did also learn fairly early on that you have to grow a pretty thick skin in order to, I don't know, keep your mental health in one piece, I guess. I think a lot of people younger enthusiasts who watch YouTube channels like yours, like ours, or any of the other automotive YouTubers sort of sit back on the couch and think, yeah, this is what I'm going to do when I grow up. It's an easy way of making a living. What would you say to that?
Learn to play games really well. I hear that's that's a little easier. No, I mean, I would say, because I was one of the negatives answering kind of the last question, but this question too is like, it's stressful to try to keep delivering on videos, right? Like you're thinking about timing and what you're going to do the next video. And then it starts to lose some of the mojo of why you're doing it in the first place.
You're creating content for the sake of creating content to feed the algorithm and keep it happy.
Correct. So it's like, it's a lot of work. It's stressful in that sense, even though it's not our daily job. We don't need, to do this. It's just, we do it for fun, but we also like to excel at, or, try to get better at what we're doing. And it so happens we're trying to get better at YouTube, which means dropping more frequently, making sure we're getting good content out there, and
trying to work on the edits. And, it's been, I mean, it's definitely YouTube. It would have been a lot easier to build this car without YouTube, but it's just another thing.
And I mean, I guess another thing is not so rosy in terms of monetary because we put in a lot more money than we've made
Oh
out of
yeah,
YouTube so
yeah,
far. So
I think that's what a lot of people who watch these bigger YouTube channels sort of see. You know, they're driving around in Ferraris and, you know, rebuilding whatever and twin turbo kits on this, that, and the other thing, and all of that is expensive. So there's this sort of assumption that, you know, they're making mad bank every month off YouTube ad revenue. I mean, there are obviously those channels that are doing exactly that, but I'm guessing for every channel that's making a lucrative living purely off YouTube, there's probably another million channels that are not making sense financially. Yeah, they're putting more into it than they're getting back. So I think it's just, yeah, it's like everything. It's not as easy as it might look like on the surface.
yeah.
yeah.
I think if it wasn't for our daily jobs, this project would. I don't even know if it would have happened, and if it had, it would look very different, right? So it's YouTube certainly hasn't. I wouldn't say maybe help is not the right word, but it's added a certain level of complexity to the project for sure.
Okay. One of the questions I've sort of had watching everything that you've done is you've built everything yourself, just like it says on the label. The tuning is one area that I didn't see you kind of dive into, and given your natures, I would have assumed that you would give that a crack too. Where's the sort of stumbling block for tuning for you guys?
I think the easy way to say it is we're scared. So, right, we built the engine, it fired, it ran. We weren't ready to push the tune in terms of getting power out of it or revving it out. So, like, you know, we did work on the startup tune. We got the driving ability tune in it, being able to go down the street for that first drive. But when it came to let's start revving it out, getting AFRs dialed in, get timing dialed in, it was like, well, we just spent 3 years building this car, 2 years we're building the engine. Let's let a pro do this one, and I could tune an LS
Yeah, we
and blow
can
it up. It
learn
doesn't
on a
matter.
different project.
Yeah, no, that does make sense. I'd sort of argue that even though it's a V10 and you're revving it to 8,000 RPM, it's difficult, not impossible, but difficult to actually damage a naturally aspirated engine. But yeah, sure, grab yourself an LS and have at it. You're going to be hard pressed to blow one of those up without really trying pretty hard, particularly in stock form. But I think, you know, as part of that as well, there's this assumption that I battle regularly that if you want to learn how to tune, you must blow up a bunch of engines. And you know, I just argue that's absolutely not the case. You know, where it gets trickier is for a novice tuner. I guess the difference between a novice tuner and a competent tuner is not so much the understanding of what to do, it's the competency and the speed with which it can be done. And if you dive into a turbocharged engine, first of all, the process of tuning the fuel and ignition is no different, but your operating window where the engine's going to be happy and healthy is narrower. And particularly once you start getting out into positive boost and higher RPM, if you run that engine lean or it's knocking for 5, 10, 15 seconds before you can kind of get it all dialed in, yeah, you could do some damage. Whereas naturally aspirated engines, just that operating window is much wider. So tuning might be something in the future for you guys, though.
Yeah, I mean, I think I want to do it. You can, I mean, like, yeah, the scared part of it is like, yeah, we'd have to go down the street to dial it in. We don't have a dyno, but maybe renting a dyno, I would like to too.
Yeah, I think, I mean, it's definitely, I think, at least I think of it, and I'm sure most people do too, it's kind of like this dark magic skill that, most people don't have. And it certainly looks that way from the outside, right? But
well, I think that's the whole reason we exist, because we started with purely EFI tuning. First of all, to create the resource that I would have loved to have access to when I was trying to figure it out myself and doing it the hard way. But also there is this mystique around tuning. and it's made out like it is some kind of black magic or some God-given gift that you're either born with or you're not. And I mean, it's obviously complete bullshit. It's just science, and if you understand the process, you can therefore apply it. But I think it's made out like this because of all these tuners who actually don't know what they're doing. So they're trying to also confuse and mystify. And I would also argue that is the main reason why ECUs have lockable configurations, is to hide the lack of understanding, of lack of knowledge of this tuner behind a password, so that others aren't going to look at it and go, this person has no clue what they're doing. It's probably a different conversation for a different day, though. But suffice to say, it's a skill that is totally something anyone can learn, given you've got a bit of eye for detail and a bit of patience. All right, I think we've probably taken up just about enough of your time, so I think we'll move towards wrapping this thing up. And of course, we've got the same three questions we ask all of our guests. The first of those is, what's next in the future for you guys and Build It Yourself? I sense you're sort of getting pretty close to the tail end of this particular project, and I'm interested. That's always a challenge. You've built this car over a number of years. You've built up a sizable following who are tuning in to see this project. What do you do when that project's finished, and how do you choose something that's going to be equally as interesting?
Yeah, I mean, we've talked about this for a while now, because it's one of those things where this type of project, assuming we want to top it, right? It took 3 years, and at the pace we work at, and because it's not a full-time job, if we wanted to build something to this caliber, or potentially even better, it's not going to be like another couple months build. It would take a long time, and I think we've given up a lot of our social life in the last 3 years to do this, and I think we have to kind of balance. Okay, is the payout worth it to kind of do another one? It's just one of those things where now we have to think, do we want to do another one like this? Do we maybe want to step it down to a more basic level where we can actually enjoy it much quicker, right? And then obviously the downside of that, or at least our thought is, are people going to watch our videos if we build just a Coyote or something? It's like there's so many of those builds out there that, okay, you kind of start questioning whether that's even a good YouTube route.
I guess that's where you have to weigh up the decision of, are you doing something for yourselves or are you doing something for the internet? And I mean, neither of those are a wrong decision, but the route you're going to take is going to be very different depending on which of those angles you're going with.
Right. Yeah, absolutely.
I mean, we have things we are interested in, absolutely want to do. It's just, how would they be received? They're not necessarily one-upping this build. I think, custom heads that we make and swapping a car from front-wheel drive to rear-wheel drive is hard to top. We've talked about it. But we have things we'd like to do that are cool, but will it convey to our audience? Is it worth it to dive into? So, yeah.
I definitely don't subscribe to each subsequent project has to be bigger, better, and more elaborate than the last. I don't think that's necessary, but that does seem to be the angle you see the automotive YouTubers go down. I guess there's a natural progression there. I think there's a lot to be said as well for doing some projects which are maybe a little bit more, will feel and look a little bit more accessible to the average person. But I think also doing more projects around simply just leveraging these technologies that we've talked about in this podcast so far, just because you're building an intake system for a custom one-off 4-valve V10, that exact same technology could be used by Jimmy in his home shed to build one for his Toyota Altezza, for example. It's exactly the same. So I think there's something to be said for that. Anyway, we'll wait with bated breath to see what that looks like. Next question, is there any advice you'd give to a younger version of yourselves to help fast track where you are today in your career, or get there faster, I should say?
I think I could give myself one thing is, don't be afraid to invest, right? Like, we're money conscious, cheap, and I'm guilty of it. And like I didn't get a 3D printer until like last year. Like why? I mean, I got a Creality, of course, but why did I wait so long? Because I don't know. I need to be able to see what you like to do and invest. There's go after it. Spend some money. It's fine. That's what I would tell myself.
Yeah, I think for me, a big one is be more, I guess, assertive. I think one thing we struggle with a lot is whenever we get to a point where we're like, well, this is not something that we should do, like machining the heads or stuff like that. I think a lot of times I struggle to figure out how to reach out for help. I guess bigger companies, like I'm just me. If I reach out to this big company, they're just going to ignore it, or they're just not going to respond, or whatever, right? So you kind of just take that leap. Don't be scared to ask for help. Just put yourself out there, and eventually most people are reasonable, and I think most people would be willing to help. You just have to get over that hump of like, maybe it's just stubbornness in me too, but that's one thing I think I would struggle with a lot, even today.
We see this a lot in the tuning industry, and I have talked about this before. I think every tuner, at least initially, I think it's a Dunning-Kruger effect as well. They think they are the best in the business and know everything there is to know. And there's an ego, I think, in the tuning world. So no one wants to reach out and kind of ask others for help. It's a sign of weakness. And I think if I look at my experience, I definitely started like that. And then the further you sort of go down the rabbit hole of tuning, you come, sort of down the sort of the Dunning-Kruger slide, I guess I'd call it. And you realize you don't know what you don't know. And you're like, oh shit, there's a lot. There's a lot that I don't know. And then you start absorbing and you learn more and more. And I think it humbles you. You realize that no one in the tuning industry knows everything. No one in any of these industries knows everything. But, I build up a good group of professional tuners both here in New Zealand and around the world that I could reach out to, like, hey, I've got this car on the dyno, I haven't seen this before, I know you deal with a lot of these cars, and we're always too happy to help. Well, I'd say that goes for most people. So worst you're going to get, I think you kind of alluded to, they're not going to answer your email or just plain say no, and that's fine, no disrespect, you move on.
Yes. Yeah, right.
All right, last question for today. If people want to follow you and see what you're up to, where are they best to do so? Where do they go and listen to this Formula One V10?
Yeah, I mean, I think the best place is visit our YouTube channel, Build It Yourself. Yeah, we have an Instagram, but I think we're pretty bad at keeping tabs on it. So YouTube is definitely the best.
And I think with full-time jobs, it's a wonder that you're managing to punch out the content on YouTube, and Instagram's just a whole nother beast to keep fed as well. So yeah, fair play. As always, we'll put a link to the YouTube channel in the show notes if people can't type in Build It Yourself all by themselves, but we'll make that real easy to find. Hey, look, it's been an absolute pleasure getting a behind the scenes look at what went into this build and learning more about the build as well as your background. So thank you so much for your time today.
Yeah, thank you.
I appreciate it. Thank you for reaching out. Again, I'd say it's an honor to talk to you really after all this time watching your videos. So appreciate that.
My absolute pleasure. Thanks, guys.
Thank you.
I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Max Fanboy from Canada, who has said, never miss an episode, love the podcast, keep it up. Well, thanks Max, appreciate your comment, glad you're enjoying it, and we absolutely intend to keep it up. If you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.